topics for this test review are definition of derivative and trig derivative and implicit and related rate. Okay, let's go ahead to number 1. Use definition of derivative to calculate the derivative of f of x is 1 over x. What is the definition of derivative? Is f prime of x equals limit h equals to 0 f of x plus h minus f of x all over h. Okay, you need to memorize this. This is a definition of derivative. Now use that. I'm gonna take a derivative of this. So limit h equals 0. Your f of x is 1 over x, right? So 1 over x plus h minus 1 over x all over h. Okay. Now limit h equals to 0, and you need to have a common denominator on the this expression right here. Common denominator is x plus h, and then x minus x plus h. Okay, all over h. Now limit h equals to 0, then this x cancel out, and you end up with negative h over x plus h divided by h means times 1 over h. Okay, so you can cancel this negative 1, and now you plug in 0 into h. So you have only negative 1 on the top, and the bottom you plug in this one 0 here into h, then x squared. So your final answer when you take a derivative 1 over x is a negative 1 over x squared. That makes sense because if you use a power law, let's change the format. This is a 1 over x. So when you take a derivative using power law, negative 1 x to the negative 1 minus 1, which is negative 1 over x squared, right? So that's basically the same thing. Okay. All right. Now, after that, if you need to practice, make sure you pause the video, and then you can always try on your own, and then you can compare. Okay. Now, let me erase this one. I need some more space. Okay. Now, next one. Number 2, how are you going to differentiate? This is quotient law. Okay. Quotient law. What is a quotient law? So let's say you have a u over v, right? When you take a derivative, denominator square, and on the top, we call low d high minus high d low. Okay, low means a v, derivative high is a u prime, minus high u, derivative low is a v prime. Okay, low d high minus high d low. It's easy to memorize that way. So when you take a derivative, this one, 2x 1 minus 3x squared. So when you take a derivative, denominator square, low d high. So low means you just copy the denominator. Derivative high, which is 2, minus high, 2x, derivative low. When you take a derivative of the denominator, 1 is a constant, so it goes away. But negative 3x squared is negative 6x. Okay, now you need to simplify. 2 minus 6x squared plus 12x squared all over 1 minus 3x squared, right? And then when you collect items, 6x squared plus 2, 1 minus 3x squared. Okay, that should be your final answer. So it's a practice about quotient law. Okay, all right. Next one, I'm gonna erase it here again, and then make sure you can always go back the video to check your answer one more time. So this one, how are you gonna do that? This one is a UV. So I'm gonna use a product rule this time. What is a product rule? Product rule is U times V when you take a derivative, U prime V plus V prime U. Okay, so you can use this. Now, so when you take a derivative of root 2x plus 1, 2x plus 1 times x cubed when you take a derivative. U prime, so that one is same as 1/2 power. So when you take a derivative, 1/2 2x plus 1 and power of negative 1/2 times, you have to do chain rule, so derivative inside, which is 2 times x cubed. So far this one is a u prime and this one is a v. Okay, so I did only that portion. Now plus v prime, so take a derivative of x cubed is a 3x squared times just u, so root 2x plus 1. So what I'm saying is that this one is a v prime and this one is u. Okay, let's see, you can simplify a little further. So these two cancel, and you can say x cubed over root 2x plus 1 plus 3x squared root 2x plus 1. I think you can leave it like that. You can make a common denominator, but I don't think that will be simplified like a lot more, so you can leave it. Most teachers will accept. Okay, now let's do next one, number 4. Okay, let's do number 4. So this one, you look at this way. I'm going to rewrite the function itself. Cotangent root x cube. Okay, so that cube means the entire one is cube. But before you do that, I need to go over then trig derivative. So sine x, when you take a derivative, that's cosine x. And cosine x derivative is a negative sine x. Tangent x derivative is a secant square x. This is something you need to memorize it. And what about cosecant x? Right? So then cotangent, right? Negative cotangent square x. Sorry, that's a negative cosecant cotangent x. Negative cosecant x and cotangent x. And derivative cotangent x, negative cosecant square x. And derivative of secant x is secant x and tangent x. Okay, so those all the rules you need to memorize. Now, so let's apply in here. When you take a derivative, first of all, power of 3 cotangent root x square times derivative cotangent using this rule. So negative cosecant root x square. Okay, derivative cotangent is a negative cosecant square, and times chain rule again. Root x derivative is 1 over 2 root x, right? Because x the 1/2 when you take a derivative, 1/2 x to the 1/2 minus 1 is a negative 1/2, so which means 1/2 1 over root x, so you get that. Okay, now let's see, you can simplify a little further. So 3 cotangent square root x, you can write this way, minus cosecant square root x over 2 root x. I think you can leave it like that. Okay, you don't need to simplify further. So you need to memorize that derivative, all the trig functions. Okay, now next one I want to talk about, I want to skip number 5. You just take a derivative twice. Now let's do number 6. Okay, the position function, they gave you this. Okay, and then what is the acceleration particle at 1 second? So your velocity first. Velocity is first derivative your position function. Now acceleration is first derivative of your velocity or second derivative your position function. Okay, you need to remember that. So your velocity is you take a derivative of the given position function, then 2t cubed plus 1 to the 1 power times derivative inside is a 3t squared. So when I simplify this one, 6 6 t square and t cubed plus 1. Okay. Now you can multiply it out. 6 t to the, when you multiply you add, so 5 plus 6t squared. So acceleration in terms of t, so when you take a derivative from here, so 30 t to the first power plus 12 t. Okay, but they ask what is the acceleration of the particle at 1 second. So a1, so 30 plus 12, which is 42 unit you have to write down. Then this one feet per second square, because it's feet and second. But acceleration is a feet per second square, and then velocity is a feet per second, and position is just feet. Okay, that's your final answer. Let's do number 7. Okay, number 7. This one, if you look closely of that equation, you have y here. So you cannot take a derivative as it is. So I'm gonna modify a little bit by cross multiply. So then y times x plus y equals x. Now I'm gonna distribute. So you can say xy plus y squared equals x. Okay, that's the second step. Now next step, I'm gonna do implicit. Okay, implicit differentiation. So when you do implicit, this one is a product rule. Okay, so it's like a uv. So when you take a derivative, the u then it's 1 times. You take a derivative this one in terms of x. Okay, 1, and then this one y, you just multiply, plus, so this means a u prime and this one v. Now v prime is basically y prime, right? Y prime times x. So that's a v prime and this one u. Now that one plus, now you take a derivative the second portion here, 2y and then y prime. That equals, on the right hand side, when you take a derivative, it will be 1. Okay, this is implicit differentiation rule. Now you need to combine like terms. So x y prime plus 2y y prime equals 1 minus y. Okay, now you factor out y prime. Y prime is x plus y prime times x plus 2y. When you factor out 1 minus y, so your final answer, y prime is 1 minus y over x plus 2y. Okay, that will be your final answer. That's how you're going to take a derivative. So what you have to do is by cross multiply, you make it like this type, and then from there you take a derivative using implicit differentiation. Okay, now let's do number 8. How are you going to take a derivative in terms of x? So left hand side is just 1. Right hand side, cosine is, we already talked about negative sign y. But since this is not x, so this is y, so you have to attach y prime, right? By implicit. So your final answer, y prime equals negative 1 over sine y. Or you can say negative 1 over sine is a cosecant y. So you can leave it like that. Okay, that's your final answer, number 8. Now number 9. So I'm gonna take a derivative this one. Theta is a same as just x. Okay, so f prime theta. Secant is a secant tangent. So secant, copy inside. Secant theta square tangent theta square times derivative theta square is a 2 theta. Okay, so you can leave it as 2 theta. Usually we put a 2 theta in the beginning, and then secant square, secant not square, theta square, tangent theta square. You can leave it like that. Okay, that's the final answer. Now let's do number 10. When you take a derivative, this one, that's power rule first. So 2 sine theta, sine x, times derivative sine x is a cosine x, right? And also second portion here, So negative 2 power O cosine x, and derivative cosine is a negative sine x. So your final answer, it will be 2 sine x cosine x plus 2 sine x cosine x. So it will be 4 sine x cosine x. Okay, you can leave it like that, or if you want to make it like little more simplified form, then twice of 2 sine x cosine x. 2 sine x cosine x is a sine 2x, right? So your final answer 2 sine 2x. You can leave it like that. But this one also acceptable, no problem. You don't have to go all the way like that. Okay. I think we can. Let's do one more tangent line. Okay, one more tangent line here. So to get the tangent line, you have to find the slope. Slope is f prime of x. So this one is x plus 1 to the 1/2 power. So when you take a derivative, 1/2 x plus 1 to the negative 1/2, and derivative inside is just 1. Okay, so when you plug in x equals 3, so you substitute 1/2. 3 plus 1 is 4, so 1 over root 4. Root 4 is a 2, so 1 over 4 is a slope. Now, then what is the y value at that time? So your f of 3 is when you plug in root 3 plus 1, which is 2. So you can say y minus y1 and slope 1 over 4 and x minus x1, so x minus 3. Okay, you can leave it like that. You don't have to make it mx plus b format. This one, point slope form, should be acceptable for the tangent line. Number 13 is you can do it, right? It's just take a derivative. Instantaneous rate of change means derivative. Okay, remember that. So what you have to do is you take a derivative, this one, in terms of x. Now let's do number 14, application of derivative. Now object is thrown straight down from the top of 220-foot building, initial velocity 26. Okay, feet per second. So write the position equation. It's good to know this one for free fall. Your h of t is your initial height plus initial velocity t plus 1/2 gt square. G is negative 32 in feet per second system. So initial height is 220. They gave you. Initial velocity is 26, but straight down, so negative 26t. Okay, and then gravity is negative 32. 32 divided by 2 is 16, so negative 16t squared. So I got this equation, so that's the answer for A. Now, what is the velocity at 1 second? So velocity at 1 second, so you take a derivative of this, h of t. When you take a derivative, that's a negative 26 minus 32t, but t is 1. So when you combine those numbers, then negative 58. Okay, so negative 58 feet per second. So that's the answer. So that's the velocity at 1 second later after object is thrown. Okay. Now let's do relative rate. So this is a relative rate, number 15. A balloon in the shape of the sphere being blown up. The volume is increasing, so dV dt, okay, they give you here, 4 cubic inches per second. So that's why that's dV dt. What rate is radius increasing? So what is a dr dt when r is 1 inch? Okay. So your volume of sphere 4/3 pi r cube. You need to memorize this one. Volume of sphere, if your radius is r, then volume is 4/3 pi r cube. Now, you take a derivative in terms of t both sides. So dV dt equals 3 cancels out, so 4 pi r squared dr dt. Okay, when you take a derivative in terms of t both sides. Now you plug in what you know. So dV dt is 4, and 4 pi r is 1, so 1 squared is 1, and dr dt. And you're looking for drdt. So that's 1 over pi, right? Because 4 cancel. And then you divide by pi both sides. So that inch per second. So it will inflate. The radius is 1 over pi inch per second. Okay? That should be your final answer. Okay, I think that's it for this video.